Hello, everyone. Welcome to this webinar. My name is Arlette, and together with the e-house expert, Oliver, we will drive you through the topic Empower Your E-House with Digital Asset Management and Condition Monitoring. Let's take a look on the agenda first. First, we're going to talk about the principles and benefits of empowering an e-house. Then we go a little bit deeper into the advantages of asset management and condition monitoring. And finally, we will present you one Siemens solution for this, the Simaris control. But what do we mean to empowering an e-house? In a traditional context, empowerment is about granting authority or power to someone to do something. And this requires three important ingredients: awareness of yourself to identify your strengths, trust, being a truthful person, and autonomy to take decisions. The purpose of empowerment in such a context is to become a better version of you and live in a meaningful way. You might ask yourselves now, what does it have to do this with energy distribution and e-houses? Well, the thing is that we can apply a similar concept to our energy distribution operations. In this case, to get a better version of our energy distribution system by giving the power to operators and maintenance teams to take better decisions and be protagonists of a transition to a more productive way to provide energy. The ingredients are going to be the same: awareness, to monitor the status of all the devices; trust in the right electrification equipment within an e-house solution; and for autonomy, the autonomy to take better operation and maintenance decisions based on system data. So, Oliver, you as e-house expert, can you tell us something about an e-house before we look how it can be empowered?
Sure, Arlette, but first let me thank you for introducing this topic to us today. So basically an e-house stands for electrical house, which already implies the usual use case. An e-house is a prefabricated containerized solution for power distribution substations. Such containerized substations provide switchgear rooms as required and can be single-lift type, multi-modular, or double-story. It's designed architectural as equipment room, according to international standards for usage in all markets. For special applications like data centers, e-house kits can be provided for rapid deployment. Mobile e-houses are installed on trailers as portable and temporary distribution solution. All use cases follow the same project idea. We, as Siemens, integrate the selected power equipment out of our EA portfolio and other power equipment, such as battery systems, and we pre-install all required building technologies for our customers. Before the modules are shipped to site, the systems are parameterized and pre-tested, considering all cybersecurity aspects applicable for product suppliers and integrators. e-house substations are a space-saving alternative to conventional substations due to compact and standardized design, reducing land use and civil costs. Having fewer on-site activities reduces typical site risk for projects. And the single contract includes the integration engineering. This reduces the interface complexity for our customers' project management, engineering, and site management. The e-house approach can provide time savings due to parallel design and manufacturing of the power equipment and the e-house structure. Overall, all these benefits can lead to CapEx savings up to 20%. But our EA portfolio offers the chance of further OpEx savings during the operational lifetime. So I'm glad that you introduced to us today how our digital IoT solution, Simaris Control, can support our customers during the operation.
Thanks, Oliver. I got it. And it seems to be a very trustful solution by itself. But let's have a look at the value add of assets data for customers. Now let's go to the second point. And to fully empower this e-house, we will focus in the operations and maintenance steps and the role of asset management and condition monitoring. E-houses, as we just listened, are the perfect solution for fast and reliable power supply and distribution. Because in these projects time is critical, very often we see that the integration of monitoring systems is not considered due to the planning and integration time needed. Additionally, on e-houses, along with the switchgear and motor control centers, the peripheral devices like those for fire detection and alarms or HVAC system play an important role for the good maintenance of the e-house. Not having a centralized monitoring system to manage all these assets in an e-house ends in frequent inspections visits by specialized personnel, loss of operational information for further analysis, limited or not transparency at all of all the systems and devices, and no means for analytical or statistical information. At the end is an absence of actual information per device. Another aspect is the maintenance, which is key to keep systems running, increase reliability of the system as a whole, and increase electrical components life cycle. Unfortunately, operators are still working on a high proportion on reactive maintenance. This despite preventive maintenance plans are in place. Nevertheless, these are normally time-based, making the preventive maintenance labor-intense and in some cases even unneeded. In contrast, we see that predictive maintenance is condition-based and can double savings up to 40%. So the first step to move into a more predictive maintenance is to have a means to know the real condition of the system. Knowledge is power, right? And to have this data in our hands can empower our e-house with a reduction in maintenance cost, reduce breakdowns, planned downtimes, and in consequence, increase production. These achievements can be different on each project, and these will depend on the amount and quality of information gathered, or better said, the transparency level reached, the frequency of information, and the access of this information by the right stakeholders. In sum, to empower an e-house, we need to consider a trustful system by hardware and design, gain awareness through asset transparency, condition monitoring, and the storage or capture of the operational information. For the decision's autonomy, is required a means to make this information accessible to the right stakeholders and to have a continuous availability of the data. I think all of you agree with me that all these benefits sound quite good, right? So now I will present to you a Siemens solution to achieve it. This is Simaris Control. Simaris Control has the necessary functions to create awareness, like the asset monitoring of all devices from low voltage to medium voltage switchgears, transformers, and peripheral devices. Also, we have a condition monitoring module specific for medium voltage switchgears. All this in an interface that presents and organizes the most important data to operators very easily to give decisions autonomy to maintenance and operators teams. The integration of Simaris Control to an e-house project, it is on hands of Siemens from design to commissioning without risking the project timeline. So now you might ask, okay, and how is that this is achieved? Well, the foundation is that Simaris Control has an open architecture principle. This allows us to integrate multiple types of protocols from different devices. We offer a local HMI with remote connection possibilities and an on-premise storage system. In this way, Simaris Control can be used as data collector and in consequence, reducing the data transfer and storage in the main control system. Simaris Control can be adapted also for future cloud connectivity if necessary. The condition monitoring for medium voltage switchgears consists in adding temperature and partial discharge sensors to the switchgear in the bus bar, the cable terminals, and is requested also in the bushing for NX-Air switchgears. These signals are collected in a reader, and this information, together with the CPROTEC 5 relays data, goes into the Simaris control gateway, where all signals are evaluated with a Siemens engine developed by our research and development department to deliver a health indication. In gas-insulated switchgears, we use temperature sensors in the cable terminals and high-frequency sensors together with a Roboski coil for partial discharge monitoring. Here also the data from CPROTEC relays is collected, and also all the signals are evaluated by the Siemens engine to determine the health of the system. Now it's time to see a demonstration of how it looks. The main view offers a representation of all the connected assets: medium voltage switchgears, transformers, Sibacon SH power distribution boards, or MCCs. Even peripheral devices from substations like HVAC systems or smoke detectors can be monitored. All assets have a digital twin representation. This shows all panels or sections and installed devices as if users were in front of the real asset. On medium voltage devices, a front mimic is illuminated in a simplified view of the switchgear assembly, showing the energy flow according to the physical status of the devices. Sibacon's 8 digital representation has all panels and devices too. This transparency of the asset is shown on device level. For example, by selecting a device on any panel, a pop-up window will display several tools, like, for example, a control function, measured values, or statistics. Also, related documentation like circuit diagrams, bill of material, or manuals. On low voltage devices, the information can be from pack meters or Simocode starters. All Sibacon SI devices are connected to Simaris control, giving us a deep level of transparency. On medium voltage devices, it's possible to see the CPROTEC relay data, like, for example, the switch state. We can see also measured values, a view with all the present faults, and the status of the relay. Simaris control provides also an alerts function. This shows current and historical alerts up to 100, with the possibility to acknowledge on sites and even to export on CSV format. To have condition monitoring, the activation of the health button is necessary. This is going to offer a clear view of the actual state of each panel of all switchgears with a color code. The condition monitoring for medium voltage switchgears provides a health evaluation of the assets based on Siemens domain knowledge rules and the continuous lecture and assessment of temperature signals. These temperatures come from bus bar, cable compartment, cable bushing, and it also considers the panel humidity. We also have the partial discharge monitoring. And it takes this real-time partial discharge measurement together with the actual relay information. Up to here today, I showed the asset transparency and condition monitoring that Simaris Control can offer. But it has many other features to help maintenance teams and operators to plan and take decisions better. So now let's go back to the presentation and let's see the conclusion of this. To conclude, what is Simaris Control? It's the on-premise solution for complete Siemens substations. Users can reduce electrical assets management time, find failures faster and accurately, increase the data volumes, and improve the performance of control systems. In this way, prevent shutdowns and boost their failure detection expertise on medium voltage with the condition monitoring system, and on top, get all documentation in digital format, organized in one place. I will close this presentation by telling you, just take the leadership of your e-house and empower it with us. You can find also more information in the following websites, siemens.com-ehouse or siemens.com-simariscontrol, or you can get in contact directly with us by email. So now it's time to listen a little bit more from you, and we can go to the round of questions and answers.
Yes, Alette, there are some questions for you. So I'll start with the first one. How is Simaris Control integrated in the e-house? Is it in the LV panel or in the MV switchgear?
That's a great question. Actually, we can do both, or even we have a third option. So the idea of Simaris Control is to have a system that is so flexible that can be customized to customer needs. So one option is to have the HMI of the Simaris Control directly in the low voltage switch panel. The second option is also to have it in the medium voltage switchgear. This can be mounted in the low voltage compartment. And the third option is also we can have a standalone panel where the Simaris Control can be mounted either inside or in another part of the close to the e-house. It depends on what are the requirements, the available space, and so on.
Another question is, can Simaris Control support devices other than from Siemens?
Also a good question. And as you mentioned, in an e-house is built based on the customer requirements. And that's not a problem for the building of the e-house. But when it's about Simaris Control, what we try to do is to make a system that is offering a solution no matter what is the devices that we have there. But we have to be careful because the level of transparency reach is not going to be the same when we have Siemens devices as when we have other third parties devices. Because from these third parties devices, what we can do is connect some signals in an electrical way and get some feedbacks in the views of the Simaris Control. But that is not a full transparency. As for example, if we are using the tool of condition monitoring, or the functioning, better say, of condition monitoring, we're really required to have some Siemens devices in it. Why? Because as I said, this requires an evaluation from an engine developed by Siemens with information of years of working and expertise on medium voltage switchgears from Siemens, and therefore this data is the one that is located in this engine. And for the moment, at least the part of condition monitoring is exclusive for Siemens switchgears. The rest, we can find some solutions in how to integrate this in Simaris Control. But as I said, the transparency level is going to be different.
I trust this clarifies this question. Another one is regarding the cloud. Is it possible to have the data of Simaris in the cloud?
Yes, actually, if that is a need, that's another way to customize the solution. If a customer says, look, I'm not quite sure of what is coming, but I would like to have an open possibility for cloud, then Simaris Control is completely compatible to that, because we are using devices that are available today, but that have the capabilities to grow in that direction. And also we have made some tests and here to check the possibility to connect to other cloud systems, for example, to MindSphere or to other private clouds. We have been able to make a connection into this.
Sounds good. Another question is regarding control. Can I have control functions in Simaris or only monitoring?
Both. Actually, we can have both. And as I said, once again, it depends on what is needed. We had some projects in which the customer wanted to have the control for the low voltage, but no control for the medium voltage, and we can make that. And of course, if there is a decision that is needed control in each of the sections of the e-house, we have the possibility to create users and to grant different access rights to each user so that not everybody can take control of the system. So that's also one security measure here.
I'm sure quite important for customers. Another question is regarding protocols. Do I need IEC 61850 protocol in all my devices?
Not necessarily. As we saw at the beginning, the Simaris Control has an open architecture. So this protocol IEC 61850 is more common to have it on medium voltage devices. And but on the low voltage part, normally we don't have also such a protocols. So the idea of Simaris Control is that we have one interface that connects everything. Not only these IP-based protocols, also we can connect some serial protocols, like, for example, Profibus. And therefore, there will be components that might have IEC 61850, but if they don't have it and they have another protocol, we can also connect to Simaris Control.
Now we come to a topic regarding our colleagues from Digital Grids, CCAM A8000. This is Simaris Control used in parallel to the CCAM A8000 automation and control?
Okay, see, Simaris Control so far, as we saw the gateway, it's the same HMI itself or any IPC system that we have. We have different IPC systems for this. But we have found this requirement from some customers, and therefore we have started some tests to make the CCAM A8000 as a gateway for Simaris Control. So it's something that is that we are considering, and if necessary, once again, as I said, is everything customizable. If you have that need, if you have that requirement, let us know, and we will be glad to tell you the possibilities and what can we do in this situation.
The next question is regarding project execution as well. Do you have a standard cooperation with Siemens MB partners for them to use Simaris Control?
Here we are talking about I guess the partner program is the question about. For the moment, we are working more, or we have seen customers more open to work on greenfield projects. And for these greenfield projects, we are doing all the engineering here in Siemens. So as Oliver, you say, the part of the e-house is completely done by Siemens, this engineering, the design, the selection, and everything. And therefore, work to have the Simaris Control also from the design from the beginning integrated. So that's why this case we have not seen at the moment necessary. But if you have many cases, or if you have one partner in which you say this partner would like to extend the install base of Simaris Control, we can discuss about it, and we can think of how can we make this cooperation.
And last but not least, the last question is regarding MV motors. Can Simaris Control support MV motors condition monitoring?
If these are directly connected, I think, well, a condition monitoring, it's something different, because normally what we are doing in that case is measuring the vibrations of the different mechanical parts of a motor in order to have a real condition of the motor. So for the moment, this use case, we have not seen it integrated in Simaris Control. If there is a need that it requires also this need of measurement, maybe we can think about it, because inside Siemens exists the hardware, at least, to make possible the measurement of vibrations in medium voltage motors. And then it's a matter to make a special development for integration into Simaris Control.
I think, yeah, the colleagues and the audition don't have any further questions.
Okay, good. Thank you, Oliver, for that. And in any case, if right now doesn't come questions to your mind and you want to have further questions or have discussions separately about specific projects, we already gave you our contact here, and we will be more than glad to attend all your future questions or all your future requirements. We would like to listen about that. Okay, then I think with this, we can close the session. We can start to thank you for attending this webinar. Thank you to all of you for having this time with us. And you know already our channels for communication in general for energy automation. Also, more webinars are to come with also more interesting topics. So don't miss that. Just subscribe here. You can see the links and the QR codes for that. And then we see you in the next webinar. Enjoy your day. See you.